Newton's second law of motion. I can investigate and describe applications of Newton's second law. Starter. Star reference brain dump. Play the YouTube video and write the formula for net force, mass, and acceleration.
The second law is all about a simple formulation. To get the force, just multiply mass and acceleration. If that's too much to say, there is an easy way. Try this abbreviation for this simple formulation.
F equals ma. F equals ma. F equals ma. Now that's the abbreviation. F equals ma. F equals ma. F equals ma.
Force equals mass times acceleration. Force equals mass times acceleration. Acceleration. Force equals mass times acceleration. Acceleration. F equals ma. F equals ma. F equals ma. F equals ma.
So, what is the formula for force? F equals ma. So we would write that net force equals mass times acceleration. And again, you can find this on your STAR reference guide that's on the back of your periodic table where you have your formulas for science. So let me get my writing tool, my web paint. And if we take this formula, net force equals mass times acceleration, we can use a formula triangle to get a formula for mass and a formula for acceleration. When you draw the formula triangle, you're going to put a T in the middle of it. Remember, multiplication always goes across in the formula triangle, and division goes up and down. So to place this formula in the triangle, you just simply read it. It goes mass times acceleration. So my mass would go here, mass times acceleration. So the only place to place your net force would be at the top of the triangle. Now I can get a formula for both of these variables. If I want a formula for mass, what I'm going to do is I'm going to cover up my mass, and your triangle reads force divided by acceleration. So mass equals force divided by acceleration. Okay, and then if we wanted a formula for acceleration, we do the same thing. Cover up your A, and your formula reads force divided by mass. So acceleration would be force divided by mass. Net force, mass, and acceleration. Isaac Newton discovered one of the most important laws of nature, the relationship between net force, mass, and acceleration. We call this inertia.
An object will accelerate in the direction of the resultant force. The bigger the force, the greater the acceleration. By doubling the size of the force, it doubles the acceleration. Also, a force acting on a large mass will accelerate it less than the same force acting on a smaller mass. By doubling the mass of the object, it halves its acceleration. The relationship between these variables can be shown by the equation F equals m times a. where F is the resultant force in newtons, M is the mass in kilograms, and A is the acceleration of the object in meters per second squared. For example, if a car has a mass of 700 kilograms and the driver pushes the car with an acceleration of 0.05 meters per second squared, then the force applied was 35 newtons. You can also use the formula to work out the acceleration and the mass. And to leave you with a cool fact, a newton is approximately the weight of an apple.
So Newton's Newton's second law, net force equals mass times acceleration. Think of mass as inertia. Newton's second law states that the net force acting on a mass causes the mass to accelerate in the direction of the force. So the object is always going to accelerate in the direction of that push or pull. A shorthand way of writing Newton's second law is net force equals mass times acceleration. Forces are always in the units of newtons. Mass is going to be in the units of kilograms. And acceleration is always going to be meters per second squared. Objects with more mass are more difficult to accelerate. If the same force is being applied to two objects with different masses, the smaller mass will accelerate more. And here you can see the vectors are the same size, so your forces, the flicks, are the same, being applied to a small object and a large mass. So the small mass is always going to have a larger acceleration to an object that has a large mass. More mass means less acceleration, unless a larger force is applied. So if we have a larger mass, we need a larger force to make it accelerate. Newton's law of force and acceleration: if the mass of an object remains constant, then the acceleration increases as the force increases. So here we have our masses are the same. Okay, so our masses are constant. Our forces are not. We're going to need a large force to have a greater acceleration. Always identify the force, mass, and acceleration. How much force will be required to move the object in each picture? So here you have a dog pulling a rock on a sleigh. So they're asking how much force, what's your net force? So if you look at your units here, they're kilograms, so here's your mass, and your unit here is meters per second squared, so this is your acceleration. So remember your formula, net force equals mass times acceleration. Here, this man is giving a push to the bus. We want to know what's the net force that needs to be applied if the mass of the bus is 2,000 kilograms and our acceleration is 0.05 meters per second. So net force equals mass times acceleration. So we have 100 newtons here. So our forces that are required for each object to accelerate would be 100 newtons of force. What direction are the forces applied in each picture? So here's the rock. The force is the pull of the dog. So the rock needs to go to the left. It's going to move to the left because that's where the force is being applied. And then here the van is going to move to the right in the direction of the force, the push. Will the rock and the van accelerate at the same rate? No, the rock will accelerate faster because it's smaller in mass. For your assignment today, you're going to complete Newton's second law, you're going to use the formula net force equals mass times acceleration. So I created an assignment in Schoology for you that you will complete and submit. Force can be defined as net force equals mass times acceleration. The formula for force is F equals M times A. To fill in the triangle here, we could drag and drop. Let me minimize this. So we can drag and drop our squares over. Hold on, let me get my pen. And instead of doing the drag and drop, I will just fill in the triangle. Remember, always multiplication is going to go across. Oops. And division goes up and down. So how would I place these variables in the triangle? Okay, if you have your formula for force equals mass times acceleration, we would place mass times acceleration, mass here, times acceleration. So your F would go here up top. Next problem. What force is required to accelerate a car at the rate of 4 meters per second squared if the car has a mass of 37.5 kilograms? We could record our answer in the griddable, but first we have to understand, well, what are they asking us for? They're asking us for the net force. So we're trying to solve for force. And then we want to see what variables did they give us. They give us acceleration, and I recognize that right away because it's meters per second squared. And then they give us mass, which is kilograms for our units. So we simply take our mass, which is 37.5, and we're going to multiply that by our acceleration of 4. And I'm just going to put that in parentheses. So when you multiply these two numbers, 37.5 multiplied by 4, you will calculate the net force required to accelerate the car. And then you would grid that whole number here and then decimals after. A boy, 50 kilograms, and his 20 kilogram bicycle are accelerating at 3 meters per second squared. What is the total force that's being applied? Record your answer in the griddable, and then you would drag and drop the circles. So let's think about that. So what are we asking to calculate? We are asked to calculate the net force. That's what we're trying to solve. So we need to know the mass that's being involved. So we have a 50 kilogram boy, but we also have his bicycle. So we'd have to add those two numbers together to get our total mass, 50, 60, 70 kilograms. That would be our mass. I'm just going to put that in parentheses because I know I have to multiply my mass times my acceleration, right? So my acceleration is 3 meters per second squared. So you would multiply again your mass times the acceleration to get your net force. Amy is driving her 2,400 kilogram car down the road, and the car produces a force of 7,200 newtons. How fast is Amy accelerating? Record your answers in the griddable. So here we can use our formula triangle to get a formula. So what we're being asked to calculate here is our acceleration. So what would be our formula for acceleration? So what we would do is we'd cover up acceleration, and our formula reads force divided by mass. So force divided by mass. And then I would plug in my numbers. So what is my net force that's given? 7,200. And what is the mass of her car? The mass of her car is 2,400. So I would simply divide my net force divided by my mass and get the acceleration. John can throw a ball with a force of 750 newtons, causing it to accelerate at 500 meters per second squared. What is the mass of the ball he threw? Record your answers in the griddable. So here we're being asked to calculate our mass. So over here, I need a formula for mass. So I'm going to use my formula triangle. I'm going to cover up my mass, and my formula reads force divided by acceleration. So let me plug that in. Force divided by acceleration. Now I just simply have to plug in my numbers that are given. So my force is 750 newtons. So I can place that over here. Divided by my acceleration, which is meters per second squared, so it's 500. So what is the mass of the ball that he threw? I would just simply divide my net force divided by the acceleration.